Here you can see the electromagnetic radiation. As I have told you, this starts with the ultraviolet, and before the ultraviolet, we have the gamma and X-rays as well. Then we have ultraviolet, then we have the violet limit here, up to which there would be start of the waveguide. So from the violet, it will start indigo, blue, green, yellow, orange, red. This arrangement you can find out. This all is the visible light. Then we can see it will start with the around 300 nanometer. It can go up to 700 nanometer. Exactly, if I say, so 320 is the exact, 680 here is the exact value. So up to which we have our visible light. So ultraviolet light we cannot see, X-rays we cannot see, gamma rays we cannot see. After the red light, we cannot see any other light. For example, near infrared, far infrared, or any other wave, microwave, radio wave, nothing we can see. So this is the whole wavelength starting from 10 to the power minus 14 gamma rays, X-rays we have up to the this point. Then after we have ultraviolet rays, this is in the meter value, right? And then we have the visible light portion, which is a very small portion in this whole wavelength you can see. After that, we have the infrared and red light, far red light, and then we have the microwave radio waves. And this visible light portion is only this portion you can see. Starting from this 3 point, it can go up to 2.0 electrovolt point. And this is in the electrovolt. And then in the nanometer, values are provided here. This is the visible light length, which is very small portion in this whole radiation coming out from the sun. So satellites are capable of not only seeing the visible portion, but they can sense the near infrared, far infrared light as well. And that's how, or the beauty of remote sensing comes here. Because we cannot see the far red, infrared, then the satellites will help us to show these bands into different visible forms. So that way we can analyze more and more things. So there are those things also we can see which we cannot able to see with our only eyes. So with the help of remote sensing sensors, we can see that as well. So I hope the sequence should be remembered to you. Sequence is very useful. The Vibgyor sequence is also helpful. That will help you to determine color wavelength if it is asked in the examination. And if suppose frequency is asked, so we know the formula. Frequency is inversely proportional to the lambda, and if you just replace this proportional value with the constant, so C would be introduced here. So this is the speed of light, divide the wavelength value, you will get the frequency in the hertz. So I hope that is clear to you. Lambda value you have to provide in meter, and wavelength light, the speed of light, that is you already know, 10 multiplied by 10 to the power 8 meter per second. So do not remember the frequency, just remember the wavelength. Frequency is asked, just divide it with the speed of light. So I hope this slide is clear to you now. Next thing, this visible spectrum, it is the important to note that this is the only portion of the electromagnetic spectrum we can associate or that we can see. And here's the concept of colors come, which we have the wavelength of Vibgyor. Starting from this, this is Vibgyor. This should be a little bit more apart. This is indigo, this is blue. And then we have, this is green. So this is how it is arranged, having different wavelength and different frequency. So I have told you, if you do not want to remember frequency, no problem, wavelength remember, you can easily get the frequency value as well. So this is, I hope, is very, very clear to you, starting from 700 nanometer, and this is the 400 nanometer. So this should be actually 380. This is starting from 380 nanometers and going up to 720 nanometers. So that was my mistake. 400 to 700, not 300 to 700. Then we have this infrared light also in this particular portion of the electromagnetic radiation. So this infrared means which is far from red or very near to red. So infrared, just after red we have, that is infrared. This infrared region covers the wavelength ranging from approximately 0.7 micrometer, or you can see 700 nanometer to 100 micrometer, more than 100 times as wide as the visible portion. So very small portion we have in the visible light, but you can see in the infrared region how large portion, how much large portion we have, starting from 0.7 going up to 100 micrometer. In the visible, it is only from zero point 0.4 to zero point 0.7. The difference, you can see how large wavelength spectrum we have under this infrared light. So that's why it is very important to sense the infrared light through the help of remote sensing as well. The IR region can be divided into two categories based on their radiation, that is the reflected IR and the emitted or thermal IR. So because if you talk about the thermal IR, thermal infrared, so every object which is having more than absolute zero temperature, so we have seen that in the Wien's displacement law, the object will emit some amount of radiation, and that radiation is thermal radiation. So that is under this infrared radiation only, and through that also we can detect some amount of light without the availability of any kind of energy, even with the absence of sunlight as well, because that emission of energy would be always there. So I hope this is clear to you. Then we have the microwave region. This is starting from 1 millimeter to 1 meter, and it is having multiple wavelengths. For example, P band, L band, S band, C band, X, KU band, K band, K band. These all are the microwave bands. And the microwave bands are again used as an information source in the satellites or in the satellite imagery. And here the multiple time you can find out the questions asked in the catalyst book, which band is useful for the calculating tree height. So calculating tree height, the second number band, this 15 to 30 centimeter band is used because majority of the trees are after this particular height. This L band is used there to measure the tree height. So that question you can find out in the catalyst book and see the answer. Then the multiple Indian satellites and the other satellites which are launched by the worldwide space agencies. So ISRO, Indian Space Research Organization, launched its first Earth observation satellite named as IRS, Indian Remote Sensing Satellite 1A in the 1988. After that, this is first Earth observation satellite. Remember that this is not first satellite. First satellite was Aryabhat, and that was a different thing that was launched too earlier. The first Earth observation satellite was the IRS-1A in the 1988. After that, it has launched a lot of operational remote sensing satellites. India has one of the largest constellation of remote sensing satellites in operation right now in the world. The information from these satellites is used for the numerous purposes covering the agricultural, environment study, the forestry, ocean resources, urban and rural development, mineral exploration, and the disaster management. For all that information, the Indian satellites are used. If you look at the present scenario, 13 satellites are operational under the ISRO, which are in the sun synchronous orbit. And they are, you can see here, resource set 1, resource set 2, resource set 2A, we have Cartosat 1, 2, Cartosat 2A, 2B, Cartosat 3. This is the Cartosat series. This is the resource set series. And we have the reset series, Ocean set for the ocean studies, Mega Tropicus. This is in the joint operation with the France. Tropicus from the France word it is. Mega is for the Indian word. So for the cloud study, the Mega Tropicus is used. Then we have Saral. Then we have SketSat 1. What you have to do here? You have to go to the ISRO's website and you have the satellite, Indian satellites list you can find out there. And the main property of these satellites you can find out on that particular page. So this is the only work you have to do externally by yourself. Go to that satellite, look at the features of this satellite. I'm not saying that remember all the things present in the satellite. At least you should take a look for what purposes these satellites are developed. What is the major thing for which the satellites were launched on that time. So that special properties or special features you can find out easily in the ISRO's website. Just go and read it once. For the sake of knowledge, at least just read it once. If any question asked from that particular section, At least with the help of options, you can hit the right answer. So for that purpose only, go to the ISRO's website and just study once the details, the work of these satellites. And there is lots of information you can get there for the Indian satellite knowledge. So I hope this portion is clear to you now. So that is only one homework given to you. Do that after the class. Then those all were the Sun synchronous orbit satellite. The 7 satellites list we have seen here. These all are the Sun synchronous orbit. Sun synchronous orbit means polar orbiting satellite. So suppose this is our Earth. The satellite's movement is like this. So this is the satellite, suppose. So the movement of satellite in the polar orbit continuously. So whole way, because Earth is rotating on this particular side as well. So on that way, by the movement of this satellite in this particular way, there would be continuous movement of Earth in this way as well in its own axis. And by after passing some time, the satellite will cover all the places of Earth and their images. So these are the sun synchronous orbit or sun synchronous satellites, which is covering the all area of the Earth. While in the case of geosynchronous satellite, geosynchronous or geostationary satellite, here these are the orbits. This is suppose the Earth, and on this particular Earth surface, the movement of the satellite is like this, in this way. And Earth is also rotating its own axis in the same way. So the satellite would be, which is present here, this is going to be stationary for this view only, for all the time. This would be facing to the same side of the Earth or same place of the Earth throughout the time. So although satellite is moving, Earth is moving, but because of movement of both, the satellite view is only to a single point, to a single area. So that would be the geostationary orbit. Geostationary orbit is mainly used for the communication purpose. Suppose we want to communicate with each other. So we don't want to communicate with the whole world. The only area we need to cover, that is only our country, for the TV broadcasting purpose. So that all mobile tower purpose. So those all satellites are geostationary orbit satellites, which are facing only to the Indian subcontinent throughout the time, throughout the year, throughout the weeks, throughout the days, 24 into 7 time, only in the front of Indian subcontinent. So these satellites are INSAT 3D, Kalpana, INSAT 3A, INSAT 3DR. So these are the satellites which are under the geostationary orbit. Then we have the navigation satellites, the satellite navigation services, which are used for GPS purpose, geo-coordinate location purpose, or geo-positioning purpose. These are the budding satellites-based system with the commercial and strategic applications. ISRO is devoted to contribute to the satellite-based navigation services to cater to the rising demands of the civil aviation necessities for the airlines. The ISRO has developed Indian Regional Navigation Satellite System, IRNSS, which is a kind of Indian GPS, you can say. So right now in your phones, we are using the US GPS system, you can say, the world's GPS system, but India has its own GPS system. Currently, this is not available in the mobile and all. This is mainly used for the aviation purpose and the military purpose. So that is the main two demand that India has to cover under this IRNSS system. And beauty of the system is that the accuracy is so much high here. In the GPS system that we have in the mobile, that is accuracy of 10 meter or 20 meter accuracy only. So if it is showing one location, so that person can be in the range of 20 meter, 10 meter anywhere. And this resolution is provided purposefully, not by the technology, you can say. Intentionally, this much error is provided to the local peoples, so that particular GPS cannot be used for the military purpose or for the any critical purpose by any country. So that's why USA imposed this error intentionally. But in the IRNS system, we have the accuracy of 1 meter or 2 meter. So this is achieved already by India, and this is facing the very wide range of India and the Indian border range, including the China, Pakistan, Sri Lanka, Bangladesh, Myanmar, all these countries, neighboring countries. A big portion of that. Those are not fully covered. Small countries like Bangladesh, Bhutan, Nepal are fully covered, but countries like China are half covered by the IRNSS system. That portion of China which is sharing the border with India. So we have IRNS Navik system, navigation with Indian constellation. That is the meaning of Navik. So this Navik word is used for the IRNSS group of satellites. If you look at this IRNSS satellite, there are combination of 6 satellites, if I'm not wrong, in the IRNSS. Few are in the geostationary mode, few are in the polar orbiting mode. 2 are, I think, in the polar orbiting mode, 4 are in the geostationary mode, and that's how they are covering the whole Indian continent. Then we have the Indian GPS IRNSS group of 7 navigation satellites. So 6 of them are continuously working and 1 in the reserved form, I think, if I'm not wrong. So if any wrong happen to the any satellite, immediately the 7th satellite will take the place of that that error producing satellite, or that satellite which is not working properly. Then we have a portal of Bhuvan. So Bhuvan, or the group of satellite, which is used to collect the information of the geospatial data. So these all are the different satellites of the Indian Space Research Organization, which is gathering information continuously throughout the globe or all over the world. So these satellites details, again, I am repeating, you have to study from the ISRO's website. You have to go there and just read the features and details of these satellites once. And then the remote sensing chapter is clear to you, I hope, and completed as well. So this is the remote sensing miscellaneous topic in the UGC-NET Environmental Science paper 2. So 2 miscellaneous topics we have already covered today, thermodynamics and the remote sensing. If anything is left and the detail about the unit 10, we will cover in the next class, and that would be the last class of this particular UGC-NET Environmental Science paper 2 preparation. So I hope you have enjoyed the today's class, and that's all about the today's class. Meet you in the next class. Thank you so much.